So you mix together a couple of pure substances, you heat them up, and sooner or later you notice that some new product has been formed. A nice way to monitor what's going on in terms of energy and time is with an energy diagram, and that's the topic of screencast 13.6. We'll take a look at what the typical layout is, what's on the x-axis and the y-axis, this little hump that you might see, like for example this one here or this one here, what those typically mean, and what happens, what the molecules might look like at this part right at the top of the hump. Things like that. This is Screencast 13.6, Energy Diagrams. Let's begin. Okay, here is a typical energy diagram. You see on the y-axis, it's a measure of energy, so it might be in joules or calories, for example. And on the x-axis, they say reaction progress. I think that's code for time, typically. It could also be no product, all product, but I would guess that time is an excellent unit to measure that. And in the beginning, you just have two reactants. It looks like here they've already gone a little bit ways and they're starting to collide. So, at the beginning it's all reactants, at the end it's all products. In between, you must have to apply a certain amount of activation energy here, about that much, you could measure it right there, to form your activated complex during the transition state. Notice how you put energy in, but you get some energy back out in this case. All of it, in fact. And then you have a net release of more energy. By definition, that must mean that energy is being released to the surroundings. They call that an exothermic process. How can you tell if it's exothermic or endothermic? Just your starting energy state, compare it to your finishing energy state. If it's lower, it's got to be exo. If it's higher, it's got to be endothermic. Requires energy overall. This hump typically does not matter because you get all of that energy back. It's interesting to think a little bit more about this activation energy and what it might mean. It might mean that it does mean that's the amount of energy you got to put in to let things go. And a lot of times the way you do that is via messing with the temperature. You heat it up if nothing's happening typically. This is one of the most common ways to overcome that barrier. And in fact, in a later unit we'll find that you can figure out at what temperature that reaction will become possible, will start to occur. And that has to do with a topic called free energy that we'll cover in our energy unit, which is coming up soon. Okay, anyhow, this one was overall exothermic by how much? By about that much. That's a little bit about energy diagrams.